Welcome. In this video, I wanted to discuss this problem which I solved in class, but in order for to make it available to everybody and for your viewing at your leisure, I wanted to make a video for it as promised. Now, the problem here is we're asked to find the temperature where the numerical value in degrees Celsius is equal to the numerical value in degree Fahrenheit. So typically, the numerical value of the temperature in degrees Celsius is not the same as the numerical value in degree Fahrenheit. But if there is such a case, what is that temperature where both the numerical values are the same? Now, because we're looking for the numerical value or the temperature where the numerical values are the same both in degrees Celsius and in degree Fahrenheit, we could designate it with a letter. So I suggest, as I did in class, we define that letter to be X. We know X by hypothesis, X in degrees Celsius is going to be the same as X in degree Fahrenheit. Of course, this is by hypothesis because we want the numerical value to be the same. But then, what is the relationship between temperature in degrees Celsius and the temperature in degree Fahrenheit? What is the relationship between the two? Well, we know that the two are related this way. That is, the temperature in degrees Celsius is given by 5/9 times the temperature in degree Fahrenheit minus 32. You might recall this relationship between temperature in degrees Celsius and temperature in degree Fahrenheit. But we want the point where both the value here is equal to the value here. And in class, we suggested that let's give this point where both of the temperatures numerically are the same. Let's give it a letter. Let's give it a name, X. Maybe for simplicity, I'm going to call it something else. Let's say TX. Let's say TX. And here means the temperature at some, at this X, point X. Now, we know that Tx is going to be the same in degrees Celsius as it is in Fahrenheit, degree Fahrenheit. So then we substitute Tx for both points. Because, again, by hypothesis, we want this value to be the same as that value. And we put a placeholder, Tx. Now, minus this 32 degrees Celsius. I'm sorry, not degrees Celsius. This is actually just 32. Now, if we were to reshuffle this equation and solve for Tx, let's go ahead and do so actually. This is going to be 9 times Tx equals to 5 times Tx minus 5 times 32. Now, if we make Tx the subject of this formula, what we're going to obtain is that Tx, let me not skip steps here. 9Tx minus 5Tx, this is going to be equal to minus 5 times 32. 5 times 32. Oops, that should be 32. Now, when we simplify this, it's going to be 4. Tx is equals to minus 5 times 32. And this gives us that Tx, again, here it's the numerical value. Tx is going to be minus 5 divided by 4. Of course, the 5 is multiplied by 32. And this is what we would obtain. And I believe if we were to punch out the numbers here, what we would find is that the actual value will be 40. So this is going to be minus 40. So there is a point where the temperature in degrees Celsius, the value of the temperature in degrees Celsius is exactly the same as the value in degree Fahrenheit. And we have uncovered that point exactly to be minus 40 degrees. Let's actually go ahead and test it out. What we have claimed here is this, is that minus 40 degrees Celsius, when converted to degree Fahrenheit, is also going to be minus 40 degree Fahrenheit. Let's again use this equation up here and test it out. Suppose I'm given minus 40 degree Fahrenheit. Let me find out what is its degree Celsius equivalent. Then let's go ahead and say T sub degree Celsius. This is going to be 5/9 times T degree Fahrenheit minus 32. Now let's plug in here the minus 40 degrees Celsius, degree Fahrenheit. Let's substitute that. What we end up with is 5/9 multiplying minus 40 minus 32. This will give us minus 72 times 5. So this is going to be 5 times 72 divided by 9. And when we punch out the numbers, or punch into a calculator the actual numbers, what we find is that this is actually minus 40. But notice now, this temperature is in degrees Celsius, it's degrees Celsius. This proves that at this point, the temperature in Celsius is exactly the same, has the exact same numerical value as the temperature in degree Fahrenheit. I hope this is clear. If any questions arise, please post them on a comment and I'll address them. We'll stop here and see you in the next video.